The objective in this worked example is to identify new derivatives that are likely to improve activity at their target, given the SAR already generated on a project. This example uses a publicly available set of human histamine H1 PKI data and searches the Kemble PIC50 knowledge base, generated by NextMove software, to find matched series that indicate new substitutions with a high likelihood of improving the binding at histamine H1. A matched series is a series of compounds that are identical except for different substituents at a single point. The suggestions are derived from comparing matched series in the input data with those in the knowledge base, which are measured across diverse target proteins. These suggestions are based on the premise that a matched series with a similar activity order in the input data and the knowledge base implies that those groups occupy a similar binding environment created by their target proteins. Given a similar binding environment, groups that have been shown to be better binders within the knowledge base have a strong likelihood of being better binders to the target behind the input dataset, in this case histamine H1. First, open the file histamine H1 by using the File Open menu. You'll see a spreadsheet containing 1,000 compounds and their measured affinity for human histamine H1 in the column labelled PKI. To start the matched series analysis, click on the Nova tab and then the arrow at the bottom. Select the Matched Series Suggestions option and click Next. In the dialog that appears, you can specify the column containing the property that you wish to improve. In this case, the column we are interested in, PKI, is already chosen, and we want to identify suggestions which increase this value, so this default option is also correct. Click Next. At this point, you can change the limitations placed on the suggestions that will be returned. In MATC, the support for a suggestion comes from the number of times it has been seen. The more frequent the order of the input series, the more likely it is that the suggestion will be an improvement. Hence, to find as many examples in the Kemble knowledge base, the compared series are generally short. The default options are to match a series of at least 3 derivatives, which must have been seen at least 20 times in the knowledge base. These defaults are acceptable for this dataset. With SAR transfer, the support for the suggestions comes from a long series of derivatives that shows a consistent trend with that seen in the input dataset. This dataset is too small to have examples with the default minimum number of derivatives, 8, so for this example, we will decrease this limit. Click on the minimum length of matched series box in the SAR transfer section and change the value to 7. Click Next. Here you can give the output dataset of suggestions a different name and control what else is reported in the output. Click all of the boxes for the MATC output and then click Next. On this last page, you can choose structural filters to exclude certain chemical groups. In this case, we will use the defaults, so click Finish to begin the matched series analysis. Once the analysis is complete, the results are shown in a table, with the MATC suggestions first, followed by the SAR transfer suggestions. The MATC suggestions are ordered by the % that improve column. When a row is selected in the dataset, the suggestion is displayed in the main Nova area and the supporting evidence is shown in a table below it. The SAR data from the input dataset is shown in the first row, which is why the target and first substituent columns are empty. The SAR data are ordered with the least active or undesirable data on the right to the most active or desirable on the left, as indicated by the colour coding in the table cells. The third row of the dataset shows one of the suggestions most likely to improve the PKI, which is the creation of the hydroxy derivative. This suggestion is based on the order of activity seen for the fluoro, cyano, and unsubstituted derivatives at that position on the displayed scaffold, seen in the input dataset. The supporting evidence for the suggestion comes from a variety of target sources and scaffolds, and more information for each entry can be obtained from either clicking on the target name in the target column, which will bring up the Kemble web page for the target, or by hovering the mouse over the scaffold image in the table, which will give an enlarged view. The first of the matching series from the Kemble knowledge base is for human Wee1 kinase, target Kemble 997779, where the series also occurs at the ortho position, matching the scaffold in our series. Note that further examples are seen in the same order for the meta and para positions, which may relate to influencing the aryl ring electronics rather than any direct effects. This pattern has been seen many times, and more than 44% of the 29 observations have shown an increase in activity. The example in row 21 is interesting because it does not follow the traditional order of halogens by molecular weight. In addition, the cyano group is not a group one might typically consider next in the series. Yet there are 51 observations of this series in the knowledge base, where this results in an increase of activity 31% of the time. You can also view the examples where the order does not match the input series for any of the suggestions by ticking the Show Negative option below the table of examples. To see the SAR transfer suggestions, one can simply right-click on the max correlation column in the main data table and choose the Sort Descending menu item. In the third suggestion, you can see that the series of aryl derivatives from the input data correlates very well with the activities of derivatives at map 3K8. For this suggestion, there is only one example, whereas some suggestions are based on multiple long series. The series in row 6 is very long and has multiple matches that correlate. This is an example where it would have been difficult to determine such evidence based on database searching, particularly given the various differences and gaps in the example series. In row 8, we can see an example where the suggested compound is a benzoic acid, which will make the suggested scaffolds viterionic. We may consider this suggestion surprising based on the fact that the reference sequence is all hydrophobic. While interesting and not the obvious next derivative to make, this may come from the exemplar structure already being a benzoic acid, and the target, Kemble 2046255, being aldo-keto reductase, and therefore this may be a special case specific to that protein. This worked example has shown how matched series analysis can generate suggestions for novel derivatives to improve the binding at your target, based on the data already generated within your own project. The applicability and suitability of suggestions also relies on many other compound properties, so the dataset of suggestions can be further prioritized in StarDrop. For example, using predictive models for physicochemical and ADME properties and target activity, and probabilistic scoring for multi-parameter optimization. For more worked examples of other StarDrop features, take a look at the tutorials section of the Optibrium website.